Hello again, and this is so today what I want to do is go over the reciprocal functions. This is page 380 to 382 in your packet. I'm going to move my face a little bit out of the way. Um, so these aren't too bad. Basically, what you have to do if you're good at graphing the sine and cosine and tangent functions, there's just one additional step you have to do when graphing the reciprocal functions. Okay, so the cosecant function, remember what that is? It's the reciprocal of the sine function, 1 over the sine function. Okay, and if we remember, this was our sine function right here. Okay, so when x was 0, y was 0. When x was pi over 2, y was 1. When x is pi, y is 0, and so on. So these values are going to be important. So first thing you always do when you're graphing a cosecant function or any of the reciprocal functions, you're first going to graph the function that it's the reciprocal of. So we're first going to graph the sine function. So this thing exactly as is, and this function just goes from 0 to 2 pi. And I'm going to graph, and it goes up to 1, down to -1. And remember, we've got these max and min values. Your sine goes through here, 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 and here. And I'm going to just draw this dotted. You can do it with different color pens if you want. Okay. But what I graphed here, first graph y equals sine of x. So that's this. I color code this so you can see that this thing was the sine function. That's not the function we want to graph, but that's going to help us to graph the cosecant function. Now, what we have to remember, just know what you know about reciprocals, okay? So if your y value is the sine of x, these values, okay, these y values, the cosecant is going to be 1 over these y values, okay? So at 0, when x is 0, your y value is 1 over 0. So anywhere where your y value is 0, you're now going to have 1 over 0, which is undefined, which is going to be an asymptote. So you're going to asymptote here. Here your y value is 0 again. You're going to have an asymptote here. Here your y value is 0. You're going to have an asymptote here. Okay. Now at these values, where your y value is 1, so that's here, or where your y value is -1, which is here, we're going to take the reciprocal. The reciprocal of 1 is 1 over 1. Well, that's still 1. The reciprocal of -1 is 1 over -1. That's still -1. Okay. However, think about a value over here. Let's say somewhere over here, your y value is 1/2. Well, if that's your y value, your reciprocal of 1/2 is 1 over 1/2, which is 2. Okay, so you're going to get a value up here. When your y value is really close to 0, let's say 1/10, the reciprocal of 1/10 is 10 over 1, so it's going to get bigger. So what happens as you approach 0 of y value, the reciprocal goes off to infinity. So this goes towards these asymptotes, and this goes towards these asymptotes. Okay, that right there is your reciprocal function. Okay, so y equals cosecant, this thing right here, is this function right here. Okay, and then it would continue on. We continue this on this way, and you'd have another little section of your graph over here, and so on. And then you'd have another one over here. Okay, and it would continue on. I don't want to use up this space over here, so we need to do this one. So let's do the secant function. Secant is the reciprocal of cosine. Okay, so I'm first going to graph my cosine graph. We're going to go from 0 to 2 pi. Here's pi, pi over 2, 3 pi over 2. And our graph of cosine starts up here, goes down, and ends up here. You can do another one over here if you want. Okay, that is your cosine graph, which you don't really need to graph. And that's not the question I'm asking you to graph, but it helps you graph the reciprocal function. Okay, so now we look at where y value was 0, we're now going to have an asymptote. Anywhere where your y value is on the wave axis because of the transformation, even if there was a shift up or down, these asymptotes will be where your graph hits the wave axis, or your midline. And then anywhere your y value up's up here, or down here, okay, because your y value is 1, the reciprocal is 1, your y value is -1, the reciprocal is -1, okay? And then you've got this. So this is this right here, one of these and one of these would be one full cycle of your cosine graph. Really, if we went from 0 to 2 pi, it would be this half of this one down here, and then this half of this one. Okay, so that's 0 to 2 pi. Or you could just do basically asymptote to the second asymptote, and you'd have one full cycle before it starts repeating. Okay, and then your cotangent graph. Hopefully we're all experts on the tangent graph by now. So your normal parent function for tangent graph goes from -pi/2 to pi/2 for your two asymptotes. So we'll go -pi/2 to pi/2. And there's your asymptotes. Okay, and then you go through here. At your quarter marks, you're at 1, so that's pi/4, -pi/4, so 1, -1. I'm going to draw that dotted. I'm going to draw another cycle, which will go from pi/2. So we'll go pi. So that would be at pi. So that's 1 pi/4, 2 pi/4, 3 pi/4, 4 pi/4, 5 pi/4, 6 pi/4. So 3 pi/2. From here to here is pi. Okay. So that is the tangent graph. Write that over here. Y equals tangent of x is this, which was this function. And these were your asymptotes for that function, for the tangent function. So now this is a little tricky because we have to graph the cotangent function. So anywhere where our y value is 0 or on the wave axis becomes, that y value is now the reciprocal 1/0, which is undefined. So zeros become asymptotes. So you're going to have an asymptote here and an asymptote here. I'm going to do that with the blue marker so we know these are the asymptotes for the cotangent function. And anywhere where your y value was infinity, the reason that was infinity, because at that value you had 1/0 or -1/0. So the reciprocal of that is going to be 0/1. So see how these zeros on the tangent graph now become asymptotes? Well, the asymptotes now become zeros. So these now are actual points on your cotangent function. Okay, and the quarter marks where your y value was 1, the reciprocal, still 1. So the quarter marks, those points are still on your graph. Okay, so now your graph goes through here, and that point, and towards this asymptote. Now notice this was helpful to draw these asymptotes with the blue, so I know those are the asymptotes for the cotangent graph. The yellow ones were asymptotes for the tangent graph. Okay, so on. So we actually did 2 full cycles of this function. Okay, now let's go and do a couple more examples. So this one, we're going to do vertical shift, phase shift, amplitude, and period. Okay, here there's a vertical shift of down 2. Down 2. Phase shift of right 3. Amplitude is, well, now a cosecant function doesn't have an amplitude, because a cosecant function, if you try to use the definition of amplitude, the definition of amplitude is your max minus your min divided by 2. Well, notice this doesn't have a max. It also doesn't have a min. So there's no amplitude for the reciprocal functions, just like a tangent function. So none. However, that A value is important, so we still want to write that down. The A value is 4, and A is usually associated with amplitude, so we're going to just take note of that here. The A value is 4, even though there's no amplitude. The period is going to be 2 pi over B. 2 pi over B is your period. So that's 2 pi divided by pi over 5, or 2 pi times 5 over pi. Pi's cancel, and you get a period of 10. Okay, so you're shifting 3 to the right. 1, 2, 3. And what we're going to do here, we first, since it's a cosecant function, we first have to graph this thing as if this were a sine function. So we're going to graph y equals -2 plus 4 sine of pi over 5 times x minus 3. Okay, so I'm going to graph this one, and I'm going to make that yellow. So we're first graphing this, and then there's just going to be one small step to graph that thing afterwards. Okay, so we're shifting right 3. So we start at 3. The period is 10. So if we start at 3 and the period is 10, we're going to end at 13. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, shift is down 2. So I'm going to go down 2. And I'm going to draw my wave axis, or my midline. Amplitude is 4. Well, the amplitude of the sine function is 4. So I'm going to go up 4 from the midline, down 4 from the midline, which gets me to -6. Okay, I'm going to erase this thing that was just showing my period. So up to 2. And I'm going to graph the sine function. Okay, so at 3, the sine function, remember the sine function normally, the regular parent sine function, starts at the wave axis, ends at the wave axis. Halfway through the cycle, I'm at the wave axis. Okay, so we started right 3, so I should be at the wave axis. At the end of the cycle, at 13, I should be at the wave axis. Halfway between 8 and 13 is 1, 2, 3, 4, 5, should be 8. Midpoint 3 plus 13 is 16 divided by 2, 8. So that makes sense. Got 5 and 5. And then halfway between here and here would be 3, 4, 5.5. And halfway between here and here would be 8, 9, 10.5. Okay, now we're graphing the sine function. It's not upside down. We don't look at that. That was the shift up or down. The A value is positive. So the first quarter mark, we should be up top. Third quarter mark, we should be at the bottom. This is one cycle of my sine graph. I'm just going to graph it. Where was? Oh, halfway through at 8, I was at the wave axis. I didn't grab that point. Okay. And that would be the sine graph. Okay. Now, we don't want to graph the sine graph. We want to graph the cosecant graph. So anywhere where you cross the wave axis, those will become asymptotes. And these max points are on both graphs. So you're going to now go up, and here we go down. So that is one cycle of your cosecant function. Okay. Okay, let's go to the next one. I'll do a couple more examples. You can watch as many of these as you need to. Maybe I'll go through, oh, we got a bunch. Well, we'll see how many we get through. Okay. Next one. So we're first going to graph y equals 3 plus 2 cosine of 3 times theta minus 20. The reason we're graphing cosine is reciprocal of secant. So we're graphing what it's the reciprocal of first. So that's going to be vertical shift is up 3. Phase shift is right 20. Amplitude is, well, there's no amplitude for a secant function, so we're going to say none. However, the A value is 2. And the period is going to be, notice we're in degrees, So it's going to be 360 over b, or 360 over 3. So 120 degrees. Okay, so we're first graphing the cosine function. So we're going to go right 20. Actually, let's do the midline first. Up 3. 1, 2, 3. There's your midline. And then from there, we're going to go up 2 and down 2 because the a value is 2. Gets us up to 5 and down to 1. Okay, we're going to go, now we can do the horizontal shift, right 20, and then the period's 120. So I'm going to just kind of estimate 20, and then my period is 120. So I start at 20 and I go for 120. I'm going to end at 140. Let's find my midpoint. Halfway from 20 to 140 is, add them up, divide by 2. So 160 divided by 2 is 80. Let's do our quarter marks also. 20 plus 80 is 100 divided by 2, 50. 80 plus 140 is what? 220. So 110. I think that's right. So this would be plus 30, plus 30, plus 30, plus 30. That looks good. Okay, my cosine graph, remember what your cosine graph looks like. Your cosine graph starts up here above your wave axis at your top of the 3 lines and ends at the top. Halfway through the cycle, you're at the bottom. At the quarter marks, you're on the wave axis. Okay, so at 20, cosine graph, we're up at the top. At 140, at the end of the cycle, we're at the top. Halfway through the cycle, we're at the bottom. And at the quarter marks, we're at the wave axis. So this is your cosine graph. Notice I'm doing it dotted, and I'll do that in yellow. Where did my marker go? There it is. Okay, so this one was in yellow. There's one full cycle, and then the reciprocal function, anywhere where you were at the wave axis, those are your zeros. They've been shifted, but those are the values that will make the reciprocal function undefined. So you have an asymptote there, and so the minimums, you're going to go through there, go down, go towards your asymptotes. Okay, that's one full cycle. That's all you have to graph. You could do the other part of this if you wanted. This one would actually go over here. Your next asymptote would be at negative 10. Okay, let's go to the next page. And let's see. Let's do, maybe I won't do all of these, but I will post answers for you. But let's do maybe one more of these. Let's do number 3. And then we'll do a tangent and a cotangent. Okay. So this one's secant. So the reciprocal of secant is cosine. So we're first going to graph y equals negative 10 plus 20 cosine of pi over 3 times x minus 3. Vertical shift down 10. Phase shift is going to be right 3. Amplitude, there's no amplitude for a secant function because there's no min, there's no max. But our a value is 20. And the period is 2 pi divided by pi over 3. 2 pi divided by pi over 3, which is 2 pi times 3 over pi, so you're going to get 6. Okay, so we're going to go down 10. All this negative 10. That's your wave axis, your vertical shift. And then from there, the a value is 20. So the amplitude of the cosine graph would be 20. So we're going to go down 20 to negative 30, up 20, which gets us to 10. Okay, we're going to shift 1 to the right. And the period is 6. So we're going to end 6 after 1. So 1, 2, 3, 4, 5, 6, which gets us to 7. Start at 1, end at 7. The cosine graph is going to start up top, ends up top, and halfway through our cycle, so 1 plus 7 is 8, divided by 2 is 4. We're at the bottom. Our quarter mark, so that's going to be 2.5, 4, 5.5. That's our cosine graph. Okay, and let's see. And that's the cosine graph. So then we're going to do, it's kind of like now is the fun part, where we take our zeros, or where we cross the wave axis, those become asymptotes. Our max and mins are on both functions. And then we'll go just draw them in the other direction. Okay. And that's good. Let's go to the next page. I'll do one or two on the next page. Let's do, I think it might be useful to do, actually, let's do the last two, which are cotangent functions. These two are tangent functions. I'll post answers, but if you need more practice on the tangent functions, I graphed a whole bunch of them in that tangent video. Okay. So this one, cotangent of 2x, we're first going to graph y equals tangent of 2x, vertical shift, none, phase shift, none, amplitude, none, but the a value is 1, the coefficient out here. And then the period, normally the period for a tangent is pi over b, or 180 over b. So that's going to be pi over, our b value is 2, so pi over 2. Okay, remember the tangent graph. Tangent graph looks like this. Okay, there's no horizontal shift, so we're going to, or vertical shift, so we're going to go through the origin. We want half of the period to the right, half of the period to the left, and we'll draw our two asymptotes. So period's pi over 2, so half of that would be pi over 4. Negative pi over 4. Halfway to pi over 4 is pi over 8. Negative pi over 8. So here's your asymptotes. Remember, I'm graphing the tangent graph first. Okay, so the tangent graph, these are asymptotes for my tangent graph. And we'll go through here. My a value is 1, so at the quarter marks, I'm going to be up at 1, down at negative 1. Okay. My tangent graph, remember, I'm doing this dotted still. Okay, now I'm going to do my cotangent graph. So my cotangent graph, anywhere here that was a 0 is now an asymptote. The reciprocal of 0 is 1 over 0. And here where we had an asymptote, that was an asymptote because it was 1 over 0. When you flip it, it becomes 0 over 1. So that is going to be, remember, zeros become asymptotes. Asymptotes become 0 when you're going from a tangent to a cotangent. Okay, and then my y value, where my y value is 1, reciprocal's 1. So at these quarter marks, those will be on both graphs. And you've got this. So that's really all you need for one full cycle of the cotangent graph, and that's this one. Okay, we will do one more down at the bottom. First, I'm going to graph y equals tangent of x minus pi. Vertical shift, none. Phase shift, that's going to be right pi. Amplitude, none. But the a value is 1. It's the coefficient of your cotangent or tangent. The period is pi. Okay, period's pi because we just get pi over b. B is 1. Okay, so now I'm shifting right pi. So this point on the tangent graph that normally goes through the origin now goes through a value of pi. Okay, so that point moved here. That's on my tangent graph. Okay, now I'm going to go half of my period to the right, half of my period to the left. Half of the period to the right, the period's pi, so half of that would be pi over 2. If I go pi over 2 to the right, I'm at 3 pi over 2. Pi over 2 to the left, I'm at pi over 2. Those are now my asymptotes. And at the quarter marks, so that would be 1 pi over 4, 2 pi over 4. This would be 3 pi over 4, 4 pi over 4, and this would be 5 pi over 4. Okay, and there, On the tangent graph, my y value a is 1, so I'd be up at 1, down at -1. So I'm just going to draw this dotted because this is the tangent graph. Okay, so my tangent graph looks like this. These were asymptotes for the tangent graph. So the reciprocal functions, this 0 becomes an asymptote, and the asymptotes become zeros. The quarter marks will be on both graphs. So now I'll go up this way and down this way. Okay. If you continued on, this would go this way. You have another asymptote over here. This would go this way. You'd have another asymptote here. Okay, but you only have to draw one cycle. All right. Hope that was helpful. And I will see you all soon.